In this video, we're going to be talking about the graph, the domain, and the range of a logarithmic function. So recall that all exponentials of the form f of x is equal to b to the x have the points 0, 1, and that's meaning that this thing has not been shifted. It doesn't have like a +1 out here or an x minus 3 in the exponent. So just of the form b to the x has the points 0, 1, and 1b, where b is this base. Okay, so since the logarithm is the inverse of an exponential, we can convert the logarithm into an exponential by doing the circle, and this becomes log base b of x equals y. Okay, so all logarithms of the function, all logarithmic functions of the form f of x is equal to log base b of x have these points on them: 1, 0, meaning if this thing hasn't been shifted around, up or down, or left or right, it's 1, 0, and then b comma 1, where b is this base right here, comma 1. Okay, and the vertical asymptote on all of them, again, unless it's been shifted left and right, is x equals 0. And we're going to use transformations, h, s, r, v. H is the horizontal shifting, s is vertical stretching or shrinking, r is for reflection across the x-axis, and v is for vertical shifts. All right, let's take a look at the first one. It says plot 2 points on the graph and draw the asymptote and give the domain and range in interval notation. Okay, so we've got this logarithm, log base 2 of x. Okay, it doesn't have anything multiplied out front. It doesn't have anything in here with the inside. It's just an x. It's not like an x minus 3 or an x plus 4. And there's no number being added to the whole thing. So this thing is not being transformed at all. Okay, so there's no transformation. It's not being shifted up or down or stretched or shrunk or reflected or anything. So this is just a basic log base 2 function. And we know that we have the point 1, 0 on this. And we also know we have the point b comma 1. Remember, b comma 1 is also there, b being the base. So the base of this is 2. So 2 comma 1. We know that the thing hasn't been shifted at all, so that this vertical asymptote right here is still x equals 0. Okay, so that hasn't been shifted at all. So I'll write the vertical asymptote right here. It's right on this line. Okay, and then I'll plot some points, 1, 0, and 2, 1. So I know this thing is going to look like this. It's going to come really close to that vertical asymptote, but not cross it. And then it'll cross through these 2 points, and it will kind of slow down as it goes out there. Okay, so it's going down forever, and it's going right and up forever. Okay, so the last question on this is, what is the domain and range? Okay, the domain, remember, domain is your x values. So it never gets on the other side of this dotted line, this vertical asymptote. Okay, so it starts at 0 and it goes all the way out to the right, which is infinity. Don't include the 0 because that's a vertical asymptote. Okay, so we write a parentheses and not a bracket. So the domain is 0 to infinity. The range, we can see it goes down. The arrow points down, so assuming it goes down forever. And this thing is still moving up. And if you go far enough out, this thing will keep going up. All right, so it goes up and down forever. That's negative infinity to positive infinity. Okay, let's take a look at this problem. We have 4 plus log 3 of x. So we've got this 4 out here. It looks like our only transformation. So since the 4 is not inside the function, like it would be written as log base 3 of x plus 4, all being inside, that's not what we have. So since it's outside the function, this means we're going to be shifting up 4. So that's our only transformation, is up 4. Everything else is not being transformed. There's no number being multiplied here. There's nothing being added or subtracted in here. So up 4 is it. So for the parent function, if this didn't have that plus 4 here, for the parent function, we would have 1, 0, and we would have 3, 1. Okay, so that's the parent function. But we know we've been shifted up. Now, up and down is your y-axis, right? Up and down is your y-axis. So if we go up 4, we're adding to the y values, which is this. Remember, this is x comma y. So if we go up 4, we're adding 4 to this number. So their new point's going to be 1 comma 4. Okay, so we can go and let me write the asymptote. The asymptote has not been shifted at all because we didn't get left or right shifts. So there we go. And let me draw that point 1 comma 4 on the graph. There we go. Okay, and now we have 3 comma 1 that's been shifted up 4. Again, we're adding to that y value, so it's going to be 3 comma 5. Okay, we go put that on there. 3 comma 5 is here, and we have our graph. It's here, and then it goes like this. Okay, so our new x-axis you can think of being up here at 4. Crosses 1, and then here's your other point up here. So the whole thing got shifted up by 4. Okay, the domain and range of this is the same exact domain and range that we had in the last problem. You can't go left of the asymptote here, but you can go right forever, so it's 0 to infinity. And the range goes down forever and up forever, so it's negative infinity to positive infinity. Okay, our next problem, we have 4 log 2 of x. Okay, so what's the 4 going to do? That's going to be a vertical stretch by a factor of 4. Okay, so it's going to stretch up and down, which means since it's a vertical stretch, it's going to multiply the y values by 4. Okay, so vertical means up and down, so up and down at the y-axis. So vertical stretch means we're going to multiply by this number right here. Okay, so our parent function has 1, 0 on it. It also has, here's the base, 2 comma 1 on it. If we vertical stretch by a factor of 4, we're multiplying the y values by 4. So when we multiply that y value by 4, it's 0, so it stays as 1, 0. We multiply this y value by 4, and it turns into 2 comma 4. 4 times 1 is 4. Okay. Our x equals 0 is our vertical asymptote. Vertically stretching an asymptote doesn't do anything to it. You have to actually move it left or right to change it. Okay, so this is still the asymptote. Okay, let's plot those points real quick on the graph. We've got 1, 0, it's here, and 2, 4, which is here. Okay, so that would look kind of like this. Okay, and keep in mind that the original function looks like this. I'll draw that, like if it didn't get transformed, we drew it earlier, but I'll draw it again. It would just be log base 2 of x, so that means this point would be the same, and then you'd have 2 comma 1, so it would look like this. So this function is just log base 2 of x, and this one up here is 4 log base 2 of x. So you can see how it got stretched, and the further out it gets, the more the difference is between these two graphs. Okay. The domain and range of this thing, let's see, we are still, the asymptote hasn't changed, so it's still 0 to infinity, and the domain and range goes up and down forever. Okay, on this problem we have negative log base 2 of x, and that's going to be a reflection across the x-axis. Reflect across x-axis. Okay, so if we're reflecting across the x-axis, it's basically our x values will just, if they're positive, they'll go negative. If they're negative, they'll go positive. Okay, so if we're reflecting this point across the x-axis, that means that our y values, excuse me, I think I said x values, our y values will change signs. But you can't change the sign of 0, right? So if it's 0, negative 0 is the same thing. So that didn't change. But when we have this point, which would be, let's see, the base is 2 comma 1. You would reflect it across the x-axis, so that would be 2 comma negative 1. Okay, the negative doesn't affect the vertical asymptote, so we still have that vertical asymptote at 0. Okay, and now we have the points 1, 0, and 2, negative 1. Okay, and I was writing those in red. Let me continue to do that. So here's your graph right there. It's reflected across the x-axis. Okay, and your original graph, if you want to know what that looked like compared to this, would just look like this. Okay, so that's the graph of log 2 of x, and this is the graph of negative log 2 of x. Okay, in this problem we have log base 3 of x minus 3. Okay, so this number is on the inside with the x, so that thing is going to make this graph go the opposite sign So it will go right by 3. Okay, it's opposite of the sign. So if it's negative, it goes right. If it's positive, it goes left. Okay, so right 3. Okay, so if we look at these points, right, remember, is the x value. So we would add 3 to the x value. So that would be 4 comma 0. Here, our initial x value is this base here, so that's 3 comma 1. But when we go right by 3, you add 3 to it, and it becomes 7 comma 1. And now we have a change in our asymptote as well. Our asymptote gets shifted right by 3, which becomes x equals 3. So here's our new asymptote over here. Okay, and we have the points 4, 0, and 7, which is out here. Say this is 6, this is 7. 1 would be there. Okay, so you have this graph right here. Okay, so the original graph, if you want to see that, of just log base 3 of x would be here, and let's see here. So that would look like this. And the asymptote on that would be here. So this green one there would be log base 3 of x, and the red one is log base 3 of x minus 3. Okay, last problem. We have 2 transformations on this. We have the 3 that's being added to the entire logarithm, which would make you go up by 3. And we have this that will shift the function to the right by 1. So up 3 and then right 1. Okay, and recall that you should do the vertical shift will be last, that's this one, and the horizontal shift will be first, which is this one. So you'll really go right 1 and then up 3. Right 1, up 3. Now it doesn't really make a difference this time because we don't have other things going on like negative signs that would reflect it or multiplying things that will stretch it. But remember to keep it in the order of HSRV, horizontal shifting, shrinking and stretching vertically, reflecting across the x-axis, and then vertical shifting. Okay, so we have our initial parent function has 1, 0, and the next one would be 4 comma 1 because the base of this is 4. So we would move right 1 up 3. So right 1 is the x value, up 3 is the y value. So we add 1 to the x value to get a 2, and then add 3 to get a 3. And then we'd add 1 to get a 5, and add 3 to get a 4. So we have 2, 3, and then 5, 4. Okay, so 2 comma 3 and 5 comma 4. Okay, our asymptote has been shifted. Okay, so we shifted right by 1. So it's now x equals 1 is our new asymptote. So there we go, right there. Okay, so our graph would look like this. Start from down here and go over there. Whereas our initial parent function, if it did not get shifted up and right, would just be log base 4 of x, which would look like this, 0, 1, or 1 comma 0, excuse me, and then 4 comma 1, which would be here. Okay, so it would be, before we got shifted twice, that's what the parent function would look like. Okay, and let's do the domain and range one more time. So this one, the domain, is everything to the right of this asymptote. This asymptote is at 1, so it would be from 1 to infinity. Can't include 1 because that's an asymptote. You can't touch an asymptote. And the range is just, again, going to be negative infinity, positive infinity.